All right, let's see just how easy it is to do k-means clustering using scikit-learn and Python. So the first thing I'm going to do is create some random data that I want to try to cluster. And just to make it easier, I'm going to actually build some clusters into my fake test data. So let's pretend there's some real fundamental relationship between these data, and there are some real natural clusters that exist in it. So to do that, I just wrote this little create clustered data function in Python, and it starts off with a consistent random seed, so you'll get the same result every time. And it takes in, I want to create clusters of n people in k clusters. So it figures out how many points per cluster that works out to first, and then builds up this list x that starts off empty. So for each cluster, for I in range k, I am going to create some random centroid of income between $20,000 and $200,000, and some random centroid of age between the age of 20 and 70. So what I'm doing here is creating a fake scatter plot that will show income versus age for n people in k clusters. So for each random centroid that I created, I'm then going to create a normally distributed set of random data with a standard deviation of 10,000 in income and a standard deviation of 2 in age. And that will give me back a bunch of age income data that is clustered into some pre-existing clusters that I chose at random. Okay, let's go ahead and run that. And now, to actually do k-means, you'll see how easy it is. All I need to do is import k-means from scikit-learn's cluster package. And we're also going to import matplotlib so we can visualize things, and also the scale thing so we can take a look at how that works in a minute. So I'm going to use my create clustered data function to say I want 100 random people around 5 clusters. So there are 5 natural clusters from the data that I'm creating. I am then going to create a model, a k-means model with k of 5. So I am picking 5 clusters because I know that's the right answer. But again, in unsupervised learning, you don't necessarily know what the real value of k is. You need to iterate and converge on it yourself. And then I can just call model.fit using my k-means model using the data that I had. Now scale, I alluded to earlier, that's normalizing the data. And one important thing with k-means is that it works best if your data is all normalized. That means everything is at the same scale. So a problem that I have here is that my ages range from 20 to 70, but my incomes range all the way up to 200,000. So these values are not really comparable. The incomes are much larger than the age values. Scale will take all that data and scale it together to a consistent scale so I can actually compare these things as apples to apples. And that will help a lot with your k-means results. So once I've actually called fit on my model, I have a model, and I can actually look at the resulting labels that I got. And then we can actually visualize it using this little bit of matplotlib magic. You can see here I have a little trick here where I assign the color to the labels that I ended up with, converted to some floating point number. And that's just a little trick you can use to assign arbitrary colors to a given value. So let's see what we end up with. Didn't take that long. You can see the results here are basically what clusters I assigned everything into. And you can see, we know that our fake data is already pre-clustered, so it seems that it identified the first and second clusters pretty easily. It got a little bit confused beyond that point, though, because our clusters here in the middle are actually a little bit mushed together. They're not really that distinct. So that was a challenge for k-means. But regardless, it did come up with some reasonable guesses at the clusters. What we ended up with here was cluster here, cluster there, and a cluster there, and a cluster down here. And it's not a bad choice. You know, this is probably an example of where 4 clusters would more naturally fit the data. So what I want you to do for an activity is to try that out. Try a different value of k and see what you end up with. You know, just eyeballing this, it looks like 4 would work well. Does it really? What happens if I increase k too large? What happens to my results there? What does it try to split things into, and does it even make sense? So play around with it. Try different values of k. So the n clusters function here, change the 5 to something else. Run it all through it again and see what you end up with. So play around with it, have some fun with it. That's all there is to k-means clustering. It's just that simple. You can just use scikit-learn's k-means thing from cluster. And again, the only real gotcha, make sure you scale the data, normalize it, or whiten it, as the case may be. Another name for the same thing. You want to make sure the things that you're using k-means on are comparable to each other, and the scale function will do that for you. So those are the main things for k-means clustering. Pretty simple concept, even simpler to do it using scikit-learn. There you have it. That's all there is to it. That's k-means clustering. So if you have a bunch of data that is unclassified and you don't really have the right answers ahead of time, it's a good way to try to naturally find interesting groupings of your data. And maybe that can give you some insight into what that data is. So good tool to have. I've used it before in the real world, and it's really not that hard to use. So keep that in your tool chest.